In this video, we are going to find the inverse Laplace transform of 7s squared plus 23s plus 30 over s minus 2 times s squared plus 2s plus 5. I hope it's pretty clear that this is my s, and this is s as well, and this is s as well, and this one is 5. So I'm doing my best to actually make the difference between s and 5. So how do we do that? Well, we learned that Laplace transform, if we apply Laplace transform to a function of f of t, we are gonna end up with a function of s. So conversely, if we apply Laplace transform, the inverse Laplace transform to a function of s, we're gonna get f of t. So our goal is to find out here a function of t. So inside here we have a function of s, and we have to produce a function of t. Now, if we take a look at the Laplace transform table, this side here is giving me the function t, so the Laplace transform of 1, it's 1 over s. So the inverse Laplace transform of 1 over s, it's 1. So the same thing. The Laplace transform of e to at, it's 1 over s minus a. So if we read it from right to left, the inverse Laplace transform of 1 over s minus a, it's e to at. But if we take a look at all these inverse, right here we have the Laplace transform. So all these functions, if we take a look at them, they don't look quite like the function that we have. So we will have to break down our function into something. We will have to break down this function here into, or this ratio, or this rational expression. We have to break it down into something simpler. So how do we do that? Well, first of all, I want to know for sure that my denominator, it's in the simplest form. Well, s minus 2, it's s minus 2, right? I cannot simplify it more. And s squared plus 2s plus 5, we try to see if we can factor it, but the solutions are complex numbers, so we cannot factor it in real numbers. So then, this is how we're going to break down using partial fractions. The first denominator is s minus 2, and so on the top we want to have 1 power less, which is a constant. And then the second denominator is s squared plus 2s plus 5, and at the numerator we are going to have 1 power less, which is a linear expression, bs plus c. So now our goal is to find a, b, and c. And to do that, first we're going to multiply by s minus 2 times s squared plus 2s plus 5. And we're going to obtain, on the left hand side, just 7s squared plus 23s plus 30. And on the right side, we're going to get a times s squared plus 2s plus 5. And then plus bs plus c times s minus 2. And again, let's not forget, our goal is to find a, b, and c. So to do that, we can solve it in two different ways. One way is to open up all the parentheses on this side and then equate the coefficients of the quadratic expression from the left hand side with the coefficients of the quadratic expression on the right hand side. So basically it would be 7, which is the coefficient of s squared, is going to be equal to a plus b, because those are the coefficients of s squared on the right side, and so on. Now, another method that we can use is to set s equal to different numbers to find a, b, and c. The first thing that we want to do is to set s equal to 2, because we're going to notice that this whole term is going to disappear. This whole thing is going to be 0. So 7 times 2 to the second plus 23 times 2 plus 30, that's the left hand side, equals a times 2 to the second plus 4 plus 5. So if we do the math, we are going to end up with 104 equals 8a. So, 104 equals 13a. So a equals 8. Very important. Now, s I could have chosen as other zeros that we can get here, but we don't have any real ones. So I'm going to say s equals 0, just to simplify my, to have it in, to choose the simplest number that I can to simplify my computations. So the left hand side is going to be 30, the right hand side is going to be a times 5 plus c times negative 2. So we get 30 equals a, we already know it's 8, 40 minus 2c, so negative 10 equals negative 2c, c equals 5, and we found one more letter. And then another type s, we can pick any number we want, so s equals 1. So on the left hand side we're going to get 60, and on the right hand side we're going to get a times 8 plus b plus c times negative 1. So 60 equals, we know what a is, so that's 8 times 8, so that's 64, minus b minus c, but c is 5. So y minus b, b times negative 1 minus b, c times negative 1 minus c. So if we do the computation here, we end up with b equal to negative 1. And we found a, b, and c. So how does that help us? Well, we can rewrite the inverse Laplace transform of 7s squared plus 23s plus 30 over s minus 2 times s squared plus 2s plus 5 equal to inverse, well, we know that the inverse Laplace transform, it's a linear operator. So we are going to rewrite this side here, this whole part, as inverse Laplace transform of a over s minus 2, so 8 over s minus 2, plus inverse Laplace transform of bs, so minus s plus 5, over s squared plus 2s plus 5. So basically, bilinearity means we can actually, the inverse Laplace transform of a sum is the sum of inverse Laplace transform. So can we calculate any of these? Well, this one, 8 comes in front, and if we take a look what is the inverse Laplace transform of 1 over s minus 2, you can take a look at in the table, and we're going to see that this formula here, the second one, let's highlight just the important ones now. The second one, it's 1 over s minus a, so inverse Laplace transform of that is going to be e to at. In our case, a is 2, so then we're going to have e to 2t. So it's going to be e to 2t. So we just found out this piece. Now let's start working on the second one, on this one. So what I'm going to do, I'm going to factor out the negative. Now I should do it here. Minus inverse Laplace transform of s minus 5 over s squared plus 2s plus 5. So I factor out the minus to make it a little bit simpler. Now if we take a look again in the table, we're going to see that we don't have the denominator a trinomial a s squared plus bs plus c, but we have it, but we can, in the table we actually have them in completed the square form. So let's complete the square in our case. How do I complete the square for s squared plus 2s plus 5? So I want it in this format, plus something, right? Well, if we take the middle term, we divide it by 2 and we square it, that is, we square it, we get 1. That one, it's actually the third term that I need to make a perfect square. But our problem had originally 5, so I'm going to add a 4, because now my first expression is still written in the correct format. I didn't change anything. Now this trinomial, it's s plus 1 squared, and then I have plus 4. So what does that mean? It means our inverse Laplace transform can be written s minus 5 over s plus 1 squared plus 4. Now if we take a look again in the table, now it's much better, right? It seems like I have maybe more than that. I can even identify that it must be this part, right? Where I don't have s, or I have s plus 1 squared plus 4, right? So in our case, it's pretty clear that a is negative 1. So at the numerator, I would like to have s plus 1 as well, right? To actually be able to conclude that my inverse Laplace transform is e to negative 1t cosine of 2t. But I need at the numerator s plus 1. So right now, at the numerator, I don't have s plus 1, I have s minus 5. Can I write from s minus 5 s plus 1? Well, I can do s plus 1 and then minus 6. Can I do that? 1 minus 6 is negative 5. So then I'm going to split it in inverse Laplace transform of s plus 1 over s plus 1 squared plus 4. And then negative with negative plus 6 inverse Laplace transform of 1 over s plus 1 squared plus 4. I even moved the 6 outside. And now let's try to identify what each means. Well, this one, if you take again a look in the table, is the inverse Laplace transform of that. It's e to negative t cosine of 2t. And if you take a look in the table for this part, that is e to negative t sine of 2t. Where do I get those, the negative t? Because from s plus 1, s is negative 1, so it comes here negative. Or, sorry, not s, a is negative 1. And then b is, here it's b squared, so b must be 2. So what did we find? We found that the inverse Laplace transform of all that expression that we had is equal to 8 e to 2t minus e to negative t cosine of 2t plus 6 e to negative t sine of 2t. So this is what we found. We found out this f of t function. Our f of t is this one. So we had a function in s, and we ended up with a function in t. This is what the inverse Laplace transform does.